Okay, the second part of 8.2 here is exploring the graphs of periodic functions. So the first part there I just reviewed the basic parts of sine and cos graphs. So just to show you what the shapes of them look like, what their starting points are at key points. And those key points were like that 0, 30, 60, 90, and then doing the reference angle measures for each of those up to 360 degrees or 2 pi. So with this we're going to look at some of the actual characteristics of the graphs of these functions. So a periodic function is a function whose graph repeats in regular intervals or cycles. So you might remember from the first part that we did there, I said within that 2 pi or 360 degrees, if you were to go past that to say 290 degrees, you would see you'd be repeating whatever value you had at 30 degrees, and then the next value at 420 will show you the same value you had at 60 degrees, and so on for both the sine and the cos. So they repeat their pattern, if you want to call it. That's why they're called a periodic function. So midline is the horizontal line halfway between the maximum and minimum values of a periodic function. So this is a picture here of a sine graph, a basic sine graph where we just have y is equal to sine of x. Our highest value was at 1. Our maximum was equal to 1. Our minimum was equal to -1. So then, to calculate your midline in between there, you would add your maximum and minimum together. So I'd have 1 minus 1 and divide it by 2. So that's 0 over 2. So my midline is at 0. Amplitude is the distance from the midline to either the maximum or minimum value of a periodic function. The absolute value is always, the amplitude is always expressed as a positive value, or a positive number. So your amplitude is equal to absolute value of, your maximum plus absolute value of your minimum. So in this one I have my maximum was at 1, my minimum was at -1, so it's equal to 2. The absolute value of -1 is just 1. Your period is the length of interval of the domain to complete one cycle. So for just a regular y is equal to sine x graph, my period for that is 2 pi or 360 degrees. So, and you'll see once you have graphs where you have added your a value in the front that it's going to make a difference as to when that period occurs, if it's going to be where you have your a value and your b value in there. But the period is just for, okay, when does it get back to its starting point and have completed all of the key points in between. So for this graph here, one cycle, my graph starts at 0, this is a sine graph, goes back to 0, but that's not one cycle because it hasn't finished going into the negatives. So then when it's back up again. So there's one period. The second period then is in this light blue. So your second period would be, I'll just do it in purple, would be going from here to here and then back to 0. And then it's beginning its third period after that. So this says, example number 1, correctly label the midline, maximum, and minimum points, amplitude, and period for the graphs below. State which graph is sine function and which graph is a cosine. Sorry, just had to do a little coughing there. Alright, so this is a sine function. We know it's a sine function because it's starting at 0. Okay, so our maximum value is right here. So our maximum is equal to positive 2. Our minimum value is down here, and our minimum is at negative 2. Our midline then is taking our maximum minus our minimum, or plus our minimum, I guess, and dividing them by 2. So I have 2 plus a negative 2, which equals 0 over 2, so it's at 0. So this is my midline going through there. Your amplitude then, amplitude is the distance going from here to here. So you could just count it. That's easy enough to count. You know it's a 4. But if you want to calculate your amplitude, there's two. I showed you one way. Those of you in pre-calc 30 might remember the other way where we did absolute value of maximum minus your minimum divided by 2. So the other way to think of that is what I showed you on the other side was your maximum plus your minimum, absolute value of your minimum divided by 2. This is the same thing. So if my maximum was at 2, and I subtract my minus 2 from there, divided by 2, I have 4 divided by 2, so it's at 0. So my amplitude would be 2. I didn't draw that in there very well, or correctly for that matter. So amplitude is just how far does it go from your midline. And then finally the period for this graph. Sorry, this would be my amplitude in there. The period for the graph would be where it goes from its starting point and then back to that starting point again. Another way to do your amplitude, or sorry, your period is to go from when it goes from its highest point to its highest point again. So from here, to go from this point here to this point here is one period. I should do that in a different color, I guess. So that would be a period right there. Or to go from the lowest point to the lowest point would be a period. Or to go from 0, so if I started it here, I go down, up, back to 0, so back to there, that would be another way of showing where the period is. So you have a few different ways of showing the period. So we said this graph is a sine function because it's starting at 0 and then making its way through its cycle. So the second graph here, our maximum value, what color did I do max in? Purple? Oh, I should have done. They went up to positive 3, minimum. It went down to negative 3. So my midline is just my max minus my minimum divided by 2. So it's 3 minus 3, which is 0 divided by 2. So my midline is at 0 again. Pretend that's going through 0. Okay, the amplitude for this then it's that. And again, this is nice and easy on here. Sometimes you're going to have graphs where they're not quite exactly on your 3 and your 3. But this one, because it's going a distance of 6, so your amplitude then is 6 divided by 2, so it's 3. And then I'll do the period in a different color. So your period then is when it goes from start to finish of its cycle. So it starts up here at 3, goes all the way down to -3, back up to 0, and then back to 3. So this would be one period. So then that would mean going from that point to that point is one period. There's another period, and there's another period. So this graph in here shows us 4 distinct periods. If you went from low point to low point, it'd be going from here to here, there to there, and there to there. Okay, so those are just some basics of kind of the, not the characteristics, but values that we look at in sinusoidal functions.